We're ready. All right. So you got your test back last day. Let me just go in here, make a little note. You guys. My 002s. Okay. So today we're gonna finally start the real, I'd say, kind of the real business math, right? So talking about money and interest payments and working our way through different types of scenarios, right? We're gonna start with the very basic simple interest scenario, right? And then work our way through for the rest of the term, moving into compound interest and then annuities, and then ending with mortgages, okay? So from here on out, it all kind of stays the same, and it's not that crazy test one stuff all over the place, okay? Last day we started and we talked about exponent rules and logarithm rules, right? So from now on, I expect you to know those, be able to apply those, and be fluent in those. How's the lighting in here? Okay. So we're not really doing any review because if we did, it would take the whole class, because that's what we did last class, went through all the rules. So for review today, I'm just gonna say, from now on, I expect you to be fluent in dealing with exponents and logarithms. Okay. That's what I'm expecting. So do all the suggested exercises, in the textbook, in the textbook from 4.1. All right, so there's going to be some for exponents and some for logs. Make sure that you just run through and do all those suggested exercises. If you are as fluent as I'm expecting you to be, it shouldn't take more than half an hour, right? And so you should just be able to bang all those out, okay? So that's where I'm expecting you to be. That's so annoying. How about today? So today, finally, we start in section 4.2, simple interest. So, let me see here. In its most basic form, right, if we're talking about an investment, right, you deposit some amount and to the bank and you let it sit there for some amount of time, right, and it has at some interest rate, it's earning interest, right, and then at the end you can withdraw the amount that you initially invested as well as the amount of interest that you've earned, right? And so that's the basic setup of an investment, which I think we're all kind of okay with, okay? So same thing for loans, just kind of reverse. We get the money and then we have to pay interest at the end, right? But loans and investments work the same way. So investments or loans, just in its most basic forms. Oh, there's no sound. Well, There is no sound, huh? How about now? Weird. I haven't changed anything. How about now? Oh, I don't know why I have a Spanish keyboard. Weird. Oh, I guess you could see my, oh, how about now? Nope. Okay. But I hear it on here. Oh, thanks. Good. Can't get to the exclamation mark. Oh, okay. Oh, that's good. Okay, good. So hopefully you get some sound. And good, because I didn't know how to fix that. So, but this little guy should be on mute, I feel like. Okay. Okay. Phew. Crisis averted. Investments or loans. We have a principal deposit. A principal deposit, okay, earns interest at some specified rate or specified interest rate for a specified amount of time to yield some amount of interest. To yield some amount of interest. Okay. So we're talking about a principal deposit, an interest rate, some amount of time, and then some amount of interest. Right, so let's develop some notation for that. So the principal deposit, we're going to be denoting by a capital P. The principal deposit. And as you've noticed with this course, there's a lot of terminology, right, that we have to keep track of. A lot of notation, right? Otherwise, we're not able to use the formula sheet, right? So we're going to go through these, and then I'll expect you to know the ins and outs of these as well. I know. So much I expect of you. Okay. Then there's some specified interest rate. So the interest rate we're going to denote by a lowercase r. Okay. So that is the interest rate per year. And you'll see that that's going to be important later. But we have to, so sometimes I'll tell you that it was 1% per month, right? So then we would have to convert that to 12% per year, right? Because R has to be per year. Okay. So then we have, so here, I'm just working through here the principal deposit, the interest rate for a specified amount of time to yield some amount of interest. Okay, so those are just the things we're defining. So the time we're going to denote by a lowercase t. Time also has to be in years. Time in years. And then finally, we have some amount of interest, right? And we've noticed before for the amounts, we use capital letters. So the amount of interest, we're going to use a capital I. The amount of interest. So if you look at your formula sheet, right, in the simple interest, your first formula in there is I equals PRT. Okay? So on our formula sheet, we have I equals PRT. Can't remember what color I used. So we're just saying that we take some principal deposit times the rate times the time that it's been in there for, and that's going to yield our the amount of interest that we've earned, right? And so what's nice here is that if we have any of these three or four things, three of these four things, I should say, we can solve for the fourth one, right? So as long as we just have one unknown, we can solve for any one of these as an unknown. So given 3 out of 4 of these terms, 3 out of 4 of these terms, we can solve for the fourth. So let's do a little example. Example 132, we're gonna write it out. Don't know why I have these written up, but whatever. If $5,000 interest is earned in 1 year at an interest rate of 7.3%, what amount was initially invested? Okay, so if $5,000 interest, hey, that sounds great, is earned in 1 year at an interest rate of 7.3%, what amount was initially invested? Okay, so just like we've been doing, right, let's write out everything that we've been given, right? So we know, we're told that the amount of interest I is 5,000. Okay. And then we're told in 1 year, so T must be 1 year. Okay. And the interest rate, lowercase r, is 7.3%, right? Or remember, we use decimals for math, for percentages, so or 0.073. Okay. We do want to check, right? The 7.3% has to be per year. If it doesn't specify, then you can assume that it's per year, right? I would only have to specify if it was per month or per day or whatever, right? So default is that it's per year, but anything else I'll have to specify. Okay. So we want to find what amount was initially invested, so find P. Okay. So we've got two options. We always have these two options. So we've got our formula I equals PRT, right? And so we could either take the raw formula and solve for P right away and then plug in our values, right? Or we can take the raw formula, plug in our values, and then solve for P. It really doesn't matter to me. As long as you use one of those ways, then that's good. Okay, so I equals PRT. I like to plug stuff in and then solve for what I'm looking for. But like I said, up to you. So I was 5,000. P is what we're trying to solve for. And the rate was 0.073. And the time is 1 year. Because we're just multiplying across here, right? There's no harm in multiplying these two together. In fact, they're just 3.073, right? You can multiply them together first before you divide them over, or you can divide them over together and then simplify them. Again, it doesn't matter to me, as long as you're showing what you're doing. So then we have 5,000 divided by 0.073. A little sloppy just because times 1, yeah, we can just drop it. Okay. So P must be 5,000 divided by 0.073. So P must be 68,493.15068. Okay. So P is the principal amount that we've deposited, right? And so has to be money. I give you all the decimal places just so you can check your calculator, make sure it's doing what it should, right? But P, if you go straight to just 2 decimal places, that's fine, right? So as long as as soon as we're talking money, right, you can just narrow it down to 2 decimal places right away if you want to. So we have to have $68,493.15 initially, invest it for 1 year at 7.3%. Good luck finding that. I think someone told me it was something, GICs are at 0.9% right now. It's going to take a little bit longer to get 5,000 in interest, or a little bit of a bigger deposit, I guess. You could do that math too. It's going to take a while. Okay. So in this course, even though these interest rates are going to be huge and lovely to look at, that's just so we get some kind of fun numbers to work with. In real life, interest rates are really low right now. So that'd be pretty depressing. So we work with bigger numbers, okay? But the idea stays the same. Okay. Any questions about that one? Oh. Okay, great. Let's do another one. Example 137. Jim's calculations show that the total interest owed to Jill on his $2,700 loan is $315.90. Okay, let's start there. So Jim's calculations show that the total investment, or sorry, total interest, yikes, owed to Jill on his $2,700 loan. Remember, loans and investments work the same way, is $315.90. Except for loans, you'll luck out and have huge interest rates. If he paid simple interest, at the rate of 0.9% per month. For how long did Jim borrow the money? So now we know the principal amount that he borrowed was $2,700. The amount of interest is $315.90. If he paid simple interest at a rate of, so the interest rate is 0.9% per month, right? So we need to sort that out first before we can do any calculations. And then for how long? So then we want to find time, right? So let's list all the things that we know here. So P, right, is the 2,700. We're also told that the amount of interest is $315.90. R is 0.9%, right, or 0.009 per month. Careful with your zeros, right? 0.9% is 0.009, really small. And we want to find T. Okay. So what I'm going to do, I'll always convert the rate to years, the time to years, and then convert back if I have to. You'll see what I mean in a sec. Okay? And I think that's good. That's the safest way to do things, right? So always make sure that the rate is in years and the time is in years. Convert those if they're not, and then do your calculations. Okay? So we first need to find the interest rate per year. So the rate per month is 0.009. So the rate per year, right, there's 12 months in a year, so we just take 0.009 times 12. .108. So for this course, we assume that a year has 365 days, 12 months, 52 weeks, all those kind of baseline things. Yeah. So we will assume 365 days in a year. Yeah, let's say 30 days in a month. $52 weeks in a year. And 12 months in a year. Okay. So those are just our assumptions. Kind of sidetracked here. Okay, so now we have our rate per year, 0.108. That's great. Okay, so now we can find T. So we have I equals PRT. I was what, 315.90. So I don't have to scroll back and forth. Guess I do. P was 2,700. R was 0.108, right? That's the one we just found, and we're trying to solve for T. I'll mix things up a little bit. I'll multiply the 2700 times 0.108. Oops. To get 291.60 T, 31590. So T, just switching sides here, must be 315.90 divided by 291.60. Divided by 291.60. So T must be 1.83 repeating years. And I'm going to leave it at that. You could convert the 0.83 repeating to months if you wanted to, but I'm not going to take it that far. Yeah, just leave it as that. That's good. Yeah. Any questions about that one? No? All right. Okay. Let's do another one. Example 138. Just paid interest charges of $169.05 on a $4,830 invoice that was 2 months overdue. What monthly rate of simple interest was she charged? So we have to find the interest rate, but we're also asked to find the monthly interest rate. Okay. So let's write this one out. Just paid interest charges. Interest charges of $169.05 on a $4,830 invoice that was 2 months overdue. Making the time 2 months, right? What monthly rate of simple interest was she charged? Simple interest was she charged? Okay. So she got an invoice, $4,830. If she paid it today, that's all she would owe, right? But she let it sit there for 2 months. And so they billed her again with an interest charge of $169.05. Right? And so we're given that the amount of interest, $169.05. The principal amount is $4,830. And the time is 2 months. And we have to find R, but monthly. Okay. So first we have to convert 2 months to years, right? So we can work with T. And again, so I like to convert T to years, and then I'll find the rate in years and then convert it to monthly. Right? So I do a lot of back and forth, but I think it's good to just use the same procedure always, right? Convert to years and then convert back if you have to. So first, we need to convert 2 months to years. So T must be 2 divided by 12 years. 2/12 of a year. I'm going to keep it as a fraction, right? If you find 2/12 on your calculator, you'll find it's 0.166 repeating. And so if you want to use the decimal, then you should keep all your decimal places in your calculator for your calculations. So then I can say, okay, well, I equals PRT. I was 169.05. P was the 4,830. R is what we're trying to find. And T, we just said, was 2 out of 12. So again, we could simplify the 4,830 times 2 over 12, right? Or bring them over and divide them by, divide 169.05 divided by those two things. So it doesn't matter how we do it. Let's say, let's divide them all over. 169.05. Mix it up a bit. Divided by 4,830 times 2 over 12 is R. Simplify the numerator and denominator individually, right? So the numerator is okay, but the denominator will do 4,830 times 2 divided by 12. Makes an even 805. So R, just switching sides here, is 169.05 divided by 805. Nice. 169.05 divided by 805. The rate must be 0.21 per year, right? Remember that that's per year. Find the monthly interest rate. Well, if it's 0.21 per year, all we do is divide it by 12 to find it per month. R is 0.21 divided by 12. 0.0175 per month. So 1.75%. Monthly interest rate is 1.75% per, or I guess I said monthly. Yeah.
Why did they not break that down? They said they're looking for the monthly rate, but then they only just give you the year.
There's some typos in there, some sloppy stuff, but yeah. Yeah, just make a note. The solutions in the textbook are incomplete, but this is what you want to do. Good. Any questions about that? Okay. So, moving on to section 4.3. 4.3, I show you the first cool thing that we're going to do on your calculator. These fancy, well, fancy, not so fancy, but really expensive calculators. So one of the cool things it can do is find the number of days between dates. Okay, so it knows if there's leap years or how many days are in each month and all that kind of fun stuff, right? So we can plug in any date to any date and it'll calculate the days between those two dates. So that's cool. So that's for the time component, right? So if I say, okay, I took out a loan on January 3rd and I paid it back on September 4th, right? How much interest did I pay? I want to pay exactly, right, for those dates. So I need to know how many days there are between those dates. Here we go. Okay. So 4.3 is, in the textbook, it just shows you what I'm about to show you, or it goes through what I'm about to show you. So the days between dates. On your calculator. days between dates, we're gonna shorthand DVD, NBD. See video, I wanna say around 35 minutes, around 35-minute mark. For instructions. I'm not going to write them out there in your textbook. Okay, but I'm going to show you. All right. Here we go. Here we go. Hopefully it's not too far away. It's about as straight as I can make it. Okay, so here we are. Okay. And so to calculate days between dates on your calculator, you're going to use, can I zoom in a little bit? How about that? So as good as I can make it. Okay. So we're going to use this dates function. Okay. You've all used calculators, so I call these your second functions, the ones that are above the buttons, right? Because you have to hit your second button, which is too bright on here, right? But it's your second button to access these second functions, right? So to get into the date, you're going to hit second and the one button, okay, for your dates. Okay. Yours will look a little bit different. Uh-oh. I only have a red pen. No deal. Okay. Can you guys see that in the back? Yeah? Okay. Red's hard sometimes, but I'll put it on here. I'll write it in the notes too. So to enter a date on the calculator, it needs a specific format, right? We need to be able to communicate with the calculator. So to enter a date, we have to enter it as month dot day year. Okay. So for example, if you want to enter September 1st, 2009, for example, right? You would enter month, so that's 09 dot day, 1 is 01, and then year is 09. Okay. So this date function has 3 levels, right? So if you scroll through, so you can use your up and down buttons to scroll through. And of course it needs to know the first date, the second date, and then it'll show you the days between those 2 dates, right? So we're gonna have date 1, right? We're gonna have date 2, and we're gonna have days between dates, right? If you enter any 2 of these 3, you can solve or compute for the 3rd one, right? So you don't have to enter just the dates and find the days between dates. If you want to know, okay, I made a deposit on September 1st, 2009, and then 400 days later, right, 400 days between dates, I took that deposit out, right? What date did I withdraw it on? So I'm going to show you how to do that. Yeah.
Is DT1 always low inception?
Yeah, it's going to be your initial date. So date 1 is your start date. date 2 is your end date, right? Okay, so let's say we put in a loan, right, September 1st, 2009, okay? And I took it out on, I don't know, January 19th, 2012. So in terms of our, before we even do it on our calculator, right, let's just set these up. So January is 01, 19 is the date, and 12 is our year. Right. So how you're going to enter date 1, I'll scroll back up to date 1 here. So when you start to enter stuff, right, here let's enter 09, 01, 09. Okay, so if we do 09.0109, right, it doesn't go to that format that we had initially until we hit enter, right? So to store things, you have to hit enter. Okay, when you hit enter, if it's in the right format, right, it should show up like so. Okay. So now you know that, okay, that's your first date. It's been stored. Now we can go through and we can enter the second date. The second date that we're going to enter is 01.1912. So date 2 is 01.1912. Again, enter. Glitchy. I moved too fast. Okay. Hopefully you're, anyone miss anything? No. Okay, so now we have these 2 dates stored, right? And so now you can go scroll down to the days between dates, and this is how you're going to show your work for using your calculator, right? You're going to write out this part on your page somewhere, right? Oh, on the days between dates. Oh, so maybe you want to compute CPT up in the top left-hand corner. If you hit compute, you should get 870. Let's see. Because you have the same amount of dates here. So change date 2 to 01/19/12. So to indicate what I'm calculating, right, or computing, I am going to put an asterisk, kind of like a star by the days between dates, right? Because then when I show it here that it's 870, I'm showing that I got the calculator to compute it for me. Right. Any questions before I switch? Yeah. I don't think we can go that far back. Oh, you can? Nice. Oh, cool. Nice. Like, so we could figure out how many days I've been alive.
There's another option where I'm showing this ACT.
Yeah, right.
Me neither. Yeah. Maybe it's something like actual, and then 360 might be like a default number of days per year. Sounds weird, but I don't know. I have no idea. Okay, so any calculator questions before I switch back to our notes? All right. Great. So we'll do lots of examples. Whee! So let's just make note of this notation in our notes. Oops. Okay. So to show work, when using the calculator, to find days between dates, we say that date 1 is something, and the format is month, month, dot, day, day, year, year. Or I guess if you wanted to go into the 19 whatevers, you can just put the whole year, and it apparently works. So that's cool. Okay. So date 1, and you're going to show date 2 in the format. And then the days between dates. Okay. Put a star by the item you are asking the calculator to compute. So I'll show you what I mean. Let's do an example here. Just steal example 139. And if the question doesn't give you a year, you can just use any year. So calculate the amount of interest owed on a loan of $3,800, which was advanced on June 17th, 2005 and repaid on October 1st, 2005 at a rate of interest of 10.75%. Okay. So let's outline all the information that we've been given. And so we've got the amount of the loan, P, 3,800. We're also given a date 1 and a date 2, so we don't have time, right? But we do have the first date and the second date, right? So we can find time. So I'm going to say date 1 is June 17th, 2005. Yeah. And date 2 is October 1st, 2005. And we're also told that the interest rate is 10.75% or 0.1075 as a decimal. Soon enough, we'll just start writing them as decimals right away. But we'll go slow. First, we need to find the days between dates to find T. So how we're going to show our work, right, is we say date 1 and date 2. And the days between dates is what we're solving for, so I put a little star by it. And up above this column, I'll just make a reminder to myself that it has to be in the format of month, month, dot, day, day, year. You do have to remember that for the test, right? Because it's nowhere on your formula sheet, right? So you have to remember that format. Okay, so in this format, date 1 is June. So 06, the date is 17 and the year is 05. Date 2, October is what, the 10th month? First day of 05. So let's enter these. So going into our date function, so second date, or the 1 button, date 1 is 06.1705, enter. Date 2 is 10.0105, enter. And then scroll down to the days between dates and compute. I get 106 days. Cool. Is everyone getting 106? Nice. So then we can say, so T must be 106 divided by 365 days in a year, right? Because T has to be in years, right? So now we can solve for, we have I equals PRT. I can't remember what we were solving for even. The amount of interest, so find I guess I should put a little note here. Find I. So P was the 3,800. The rate we said was 0.1075. And the time is 106 over 365. So because we're multiplying and dividing, we can do them in any order, right? Doesn't matter. So I'll do the 106 divided by 365. I'll just simplify it. You don't have to, but just to show what it is. So I still have 3,800 times 0.1075 times 0.290410959. So you can check your work. Now I can times that by 0.1075 times 3,800. I is 118.6328767, or if you wanted to just go straight to 2 decimal places and say I is $118.63, that's fine by me. So these 2 steps here are optional. I'm just showing extra work. Okay. Questions about that one? Okay. Let's do another example before we get going here. So example 140. So on June 26th, Laura put $2,750 into a term deposit until September 3rd, when she needs money for tuition, books, and other expenses to return to college. Sound familiar? For term deposits in the 60 to 89 day range, her credit union pays an interest rate of 4.25%. How much interest will she earn on the term deposit? For some reason, okay, well, whatever. I wanted it to be a different question. No. Okay. So again, let's figure out what we're given here. So we've got the first date, June 26th. If there's no year specified, right, we can pick any year, right, assuming that they're in the same year. And so our first date is June 26th, and our second date is September 3rd. So I'm going to write those two together. So I've got date 1 is June 26th. Pick any year, say 2018. Right, pick your favorite year. Date 2, let's just get that one out of the way, is September 3rd of the same year. So whatever year you pick should be the same. And the principal amount that she invested was $2,750. And the rate that she's offered is 4.25%, right, or 0.0425. Okay. So find T. We have date 1, date 2, and the days between dates. Any year. So if it doesn't specify, right, you can pick any year that you want as long as you pick the same year for both of them. So we have month, dot, day, year. The month is June 06.26, and we said 2018. And date 2 was September, so 09.0318. And then I'm computing the days between dates, so I'm going to put a star beside it. So now, back into our date function, second date, and 06.2618, enter. 09.0318, enter. Scroll down to your days between dates and compute, and you should get 69 days. So now we can solve the problem. What do we want to find? So how much interest? So find I. Okay. So we know I equals PRT. So I must be our principal amount, which was $27.50, right? $27.50. The rate, 0.0425. And the time is 69 divided by 365. So I'm just plugging in that 69 over 365 right away as we get more comfortable. So now I'll show a little bit less work. So 69 divided by 365 is 0.189, but I'm not going to write it down. I'm just going to multiply through. So times 0.0425 times 2750. The amount of interest she earned is a whopping $22.09. It's not very exciting. Wah, wah. But better than nothing, which is what we get with our interest rates. Well, we get even less. Huh? Less than nothing, no, but pretty close. Approximately nothing. Any questions about that one? Okay, so we will do more with the finding the days between dates right? Just let's say, just as just as a quick example, just to show you, find the number of days you've been alive. So for me, it's the same example. That's not what I wanted to do. I want to know, here. Find the date you were 1,000 days old. Because I want to show you that you can use any of the two to find the other one, but I keep finding the days between dates, and that's how we're going to use it, right? But I just want to show you. So for me, I'm born April 30th, 1986. What? Yeah, it's true. 40 years after the King of Sweden. Also, May 1st is always a holiday in Sweden. And then we moved. It's like, Emily, no. So then date 2, that's the one I want to solve for, right? So April 30th, 1986, putting that 1900 into the test here. I should have left myself some more room here, but I want to do 04/30, 1986. See if it works. Oh, it just knows that it's not in the future? Oh, cool. Even better. Oh. Okay, cool. So, all right, that's cool. I guess there'd be some overlap that it doesn't know, but it's a non-issue, I think. So 86, even better. So date 2, we're solving for the days between dates. I want to force it to be 1,000 days. Here we go. We can do it. Finally, I've got this example under control. 04.3086. Well, for me, you can do yours. Enter. Don't do anything for date 2. You can just leave it. Days between dates, I'm forcing it to be 1,000. Enter. And then I can scroll back up to date 2 and hit compute. Looks like it's saying it was a Tuesday.
Yeah, mine says Tuesday too.
Did you use the same dates?
No,
No?
use my own dates. Okay.
Oh,
It's just letting us.
nice. Like, give it up for the Tuesdays. That is pretty cool. Tuesday, January 24th. Here, this is something that I would never have known until today. Huh? Cool. So I guess that's when I was 1,000 days old. Time flies when you're having fun. Okay, so that was just to show you that you can solve for any one of those 3. Right? You just leave it empty or leave it and then come back and hit compute and it'll find it. Okay, so But like I said, for the most part, we're just gonna use it to find the days between dates, right? Not anything else. Any other questions? I like that it tells you the day too. Tuesday, Wednesday, Thursday. Nice. So section 4.4, moving into timelines. Okay, so timelines. We're going to use timelines for our problems because soon enough, they're not going to be as simple as, you know, I invest some money and it grows for some amount of time and then I take it out and we're done, right? So it could be something like I invest some money at some interest rate and then I invest a little bit more a little bit later and then I pull some out and then the interest rate changes and then I put some back in a little bit later and things just get kind of mumbo jumboed. So for our problems, we're going to be using timelines to show kind of the progression of what's happening, right? And it's also a way of showing our work. So on a question out of 10, for example, most of the questions are going to be out of 10. The timeline is going to be worth 4 marks. So that's a lot of marks, right? And so I want to go through and show you exactly what I'm expecting for these timelines so that you can have really good timelines, right? Because that's also going to help you lay out what you know, what you need to solve for, right? And so instead of saying, okay, we're given all these things, we have to find whatever, right? This is what's going to replace that now, right? Because we put everything into a timeline and then we can see what we need to solve for. Okay? So in its most basic form, a timeline, you're going to start with your initial date and just draw a line to some end date. Okay. So your timeline is always going to start like this, right? And above these ticks, you're going to put either the dates if you know them, right? So January 1st, 2005, let's say, to September 9th, 2010, let's say, something like that. Okay. Or you can just say, okay, well, here I am today, and then here's later, right? So up above here, you're going to put your dates. And so let's do that. So here I am today, running to the bank. Stickmen not included. And then later, right, whatever, later, here I am again, but now I'm rich. So just, we're gonna have today and then later in the most general form. Okay, so some other information that we have, right? We have some principal amount that we've invested, right? And so where we put that is below today. So let's say I went to the bank and I invest some amount P, right? Then I write that P down here, right? To show that, okay, the P is being invested here. And then I draw an arrow from P all the way to later to show that that P is sitting there until later. Okay. So I've invested some amount P and it grows. So you have to have that arrow. And then later I'll have P plus I, right? The principal amount that I invested plus the amount of interest that I've earned. Right? So on this line, this arrow, I'm going to show the time, right? Because we have to write down, okay, how long did it sit there? And so on this arrow, we're going to show that t equals whatever it is. And then the rate doesn't really go anywhere, but we have to show it somewhere. So let's just put it below the time. So P plus I, right? We don't just write P plus I. You've probably heard of the future value. Right? So the future value, right, at a later date is the principal that you invested plus the amount of interest. Right? So future value. So this, oops. That's everything that you have to have for a complete timeline. Okay. So we must have all these components for a complete timeline. So that's important. Okay. I called this point later. Technically, it's called the maturity date, right? The questions in the textbook might use maturity date. I probably won't call it anything, right? But just so you know that at the end of the term, right? So here we've got a term, right? And so the end date is the maturity date. So the maturity date, just so you're not confused when you're reading questions in the textbook, maturity date is the last date of the term of the deposit or the loan. I'll put that here. Term of the deposit or loan. So we said that the future value is the principal plus the amount of interest. Oops. So that means that we have FV, future value, right? Even though we have two letters, it's just one thing, right? One variable is P plus I. You'll notice, right, that that's not what's on your formula sheet. I'll show you where the one on your formula sheet comes from, right? Because we know that I can be replaced with PRT, right? And so we can say that the future value is P plus PRT, right? That's the same. Now I've got this common multiplier of P that I can pull outside the brackets. So then I have P times 1 plus RT. And that's where the formula on your formula sheet goes or is from. Future value, future value. So this one's on your formula sheet. But they're related, right? But if you want to find the total amount that you have at the maturity date, right, then you can just use the future value formula, right? And it's going to be So this one is the one that we're going to use the most, right, out of all of these simple interest formulas. Okay. Just like before, right, we have how many terms in here? We have 1, 2, 3, 4 unknowns, right? 4 variables. And so if we know 3 of these, any 3 of those 4, we can solve for the 4th one. So just like before, so given 3 of the 4 variables, those variables are the future value, the principal amount, the rate, or the time, we can solve for the 4th. For the 4th. So let's do example 141. Calculate the maturity value, bless you, of a $15,000 investment at a simple interest rate of 4.75% after 1.5 years. Okay. So what I want to start doing, right, is start drawing these timelines. Right? And so even though this one's nice and easy, right, to kind of wrap our head around, we'll start building timelines for these, and then it'll get easier to get into the timelines. Okay. So I know I have to start with something like this. Right? And even though I don't know the beginning date and the end date, that's okay. We can just say something kind of like today and later, or let's call it the maturity date. I like today and later, or now and later. But let's be proper and call it the maturity date. Okay. So we're told that the 15,000, that's the principal amount, right? And so below today, I'm saying that I'm going to invest 15,000. And then I'm going to draw an arrow from that to the maturity date. Okay. So that's going to become some future value. Right. And if there's anything that you don't know, right, in particular, you can just use the variable name, right? And that's just saying that that's something you have to solve for. Okay. So we have to solve for the future value. We also have to put the time and the rate on the arrow, right? So the time we know is 1.5 years. And the rate was 0.0475, right? Converting it to a decimal right away. So this is a complete timeline. So it's showing that we have to solve for the future value. Okay, so now we can use our formula. The future value is P times 1 plus RT. P was 15,000 times 1 plus the rate is 0.0475, and the time is 1.5 years. So we have to deal with the brackets first, right? And then we have multiplication inside the brackets right? So you have to use BEDMAS, it's very important. So you're gonna have 0.0475 times 1.5. And I'm gonna show my work a little bit more than you have to, just to make sure that we're all on the same page. 1 plus 0.07125. Even this, I'm gonna show plus 1. 15,000 times 1.07125. And then I'm gonna multiply it by 15,000 times 15,000. So I have a future value of 16,068 and 75 pennies even. That is great.
I use the time value of money functions on the calculator.
Did you use 4.75 as your rate? Or did you use 0.0475? Oh, use 4. Yeah, so if you want to jump ahead and use these buttons, then the interest per year has to be as a percentage.
Yeah, so I think 4.75.
Oh, did you?
Yeah.
Mm.
Try again, maybe it's
Yeah. Should be.
65 times 1.5.
Yeah.
Yeah, I get 19,453.
I don't know.
Something to do with the payment.
Potentially. Should just have 0 there.
Yeah,
I don't know. Yeah, I don't know the time value of money buttons for these kind of easy. Oh, I don't think it does simple interest. That's why. Yeah. I'm pretty sure it doesn't do simple interest. But don't worry, we'll be out of simple interest in no time. And then we can just use our calculator instead of doing the calculations. Nice, right? Okay, so let's do another example. Maybe one where we have to solve for P instead. Not too bad. Example 144. So, what amount should be invested today in order to receive a maturity value of $17,000 in 8 months if money earns 9% simple interest? So at the end, we have to have 17,000, right? So now we're working backwards to find the principal amount, right? So I'll show you how to show that on our timeline. So we start drawing our timeline. And so we have today and then later. Right? You can call it the maturity date if you want, or because there are no dates attached to these, we can just kind of name them whatever we want. Right? But they do say that we have to talk about today. Right? So we want to have a value of 17,000 at the end of it, right? So now we're forcing our future value to be 17,000. So now to show that we're bringing that 17,000 back to a principal amount today, we draw the arrow going backwards to today. And then we put a P here to indicate that we have to solve for the principal amount. Same thing though, on the arrow we say that T is 8 out of 12, right? 8 months, 8/12ths of a year. And the rate is 9%, so 0.09. So there's a, yeah. On the test, if I need to see a timeline, yeah, I'll say include the timeline. So include a timeline. For these, you don't have to, right? But I just want to get everyone in the habit of seeing timelines, knowing what's a complete timeline, because that's where I dock a lot of marks usually. Historically, the timelines are where people lose marks, right? So you might know exactly what you're doing, but you can only get 6 out of 10 if you don't have a timeline, right? That sucks. Okay? So we have to have proper timelines. Okay, so now we can get to work. We know the future value is P times 1 plus RT. Here, I like to just plug in my values and then solve for P. So that's usually my go-to. And my reasoning is that I only like to keep track of one formula, right? And so, and for simple interest, you're only given this one. You can develop the formula for P, right? So you can first find P from the bare bones here, right, by dividing both sides by 1 plus RT, right? And then you've got P. So if you, oh, this one has low battery. Nice. Okay. So if you draw on your timeline and you see, oh, I have to calculate 3 different P's, right, and that's going to happen, then maybe develop this general formula for P before you get going, and then you can just use it and reuse it and just plug stuff into it right away, right, instead of solving for P every time. Just that. And all you would have to do for showing work is you would have to say that, well, then P must be the future value over 1 plus RT. And then now you can just go ahead and use that throughout the rest of the test. But as long as you've shown me how you got that formula once, you can use it over and over again. Right. So, okay. What do we know and what do we want to find? We want to find P. So let's just plug in our values here. P, I'll just rewrite it here. Future value 1 plus RT. Our future value is 17,000 over 1 plus R, which is 0.09, times T, which is 8/12. So we need to simplify the denominator before we get going. So we get 8 divided by 12 times 0.09 plus 1. So we have 17,000 divided by 1.06. 17,000 divided by 1.06. I get $16,037.74, or this one I should show you rounding, 0.73585. So P must be $16,037. Oh, $16,037.74. Any questions about that one? How about let's get the blood flowing a little bit with example 147. Gotta get it all. Gotta catch them all. So, okie dokie. Chunky Finance Company advanced 3 loans to Dee. $2,200 on June 23rd, $1,800 on August 5th, and $1,300 on October 31st. Okay, I feel a timeline coming on, right? Just to keep these things straight. So simple interest at 7.25% was charged on all 3 loans. Right, later on, we might not have the same interest rate for all of these, right? So keep your eyes out for that. So, and all were repaid on December 31st. When some bonds that she owned matured. I like that they have to justify how she paid them off. When she robbed a bank and paid off her loans. What total amount was required to pay off the loan? Right? So first thing you're going to do for one of these questions, right, is figure out how many dates are we talking about here. We're talking about June 23rd, and then August 5th, and then October 31st, and then they were all repaid on December 31st. So we have to have that on our timeline as well. So we're going to have 4 dates on our timeline, each date just represented by a little tick. Right? So we draw our timeline. The spacing doesn't matter for the ticks, right? We just need to have 4 ticks on here. 1, 2. And of course, we list them chronologically. It is a timeline after all, right? And so we've got here, we've got June 23rd, or sorry, yeah, June 23rd, August 5th, October 31st, and then they were repaid on December 31st. Okay. So then below each of these ticks, we're going to put the amounts that she borrowed, right? Investments and loans work the same way. So she borrowed $2,200 on June 23rd, $1,800 on August 5th, $1,300 on October 31st, and then they were all repaid on December 31st. Okay. So because we want to show that all of these, right, all of these get pulled to December 31st to figure out how much she was owing, right, total. And it gets a little messy because we like to write our, okay, this arrow, then this arrow, then this arrow, but just to keep the arrows clean, I actually build my arrows from the closest date, the next closest date, right, so that it ends up looking, and it doesn't matter, it just makes it look a little bit cleaner. Okay. So 1,300, I'm going to pull forward to December 31st, and that's going to be a future value, right? But I can already tell that I'm going to have 3 different future values, right? So I'm going to say this is future value subscript 1, for example. So future value 1. That's something I have to calculate. Okay. Later, we'll use the subscripts to denote the order that we have to do our calculations in. Here, it doesn't matter, right? We have to solve for each of these future values. It doesn't matter which one we do first, right? So the subscript doesn't matter. But here, I'm going to have future value 2. And then here, I'm going to have future value 3. And then here, I'm going to show that if I add these together, I'll find the total owing. And the rate we're told for all of these is 7.25%. So I'm just going to put the rate somewhere down here, right? Because we just need to have it on our timeline, right? So the rate is 0.0725. If each of these arrows had different rates, right? So maybe the rate changed for this loan, right? then you would attach it to each of the arrows, right, to show that it's different. Okay, but for now, we have this overall rate, so I just kind of write it down below. Okay. You only have to write it once. Last thing we need, right, is we need to find, okay, well, T subscript 1 is the time, right, between October 31st and December 31st, and that's the time that we're going to use for future value 1. T2 and T3 we have to find. No. So find T1. You're going to use the days between dates, of course, right? So date 1 is October 31st. October is the 10th month, 31st day, and the year, let's say this year or any year. Right. Date 2 is December 31st of the same year, right? We're assuming in the same year. So December is 12.3118. What's nice is that that's going to be your date 2 for all of these, right? So once you've entered it, you just don't have to change it every time, right? You can just keep it as date 2, keep changing date 1, and calculate the days between dates. So I want to calculate the days between dates. So I'm going to indicate that with a star. I'll just put a little reminder here that I need month, month, day, day, year, year. Okay, so what do we get? Second, date function, 10.3118, enter. Oh man. Pretty sure it was at 100% when I got here, but okay. Date 2, 12.3118, enter. Days between dates, compute. I get 61 days. So now I can fill that in, and I need to fill it in on my timeline, right? T1 is going to be 61 out of 365 days. Okay. So we can find T2. Date 1, date 2. Days between dates is what we're calculating. Date 2 is still 12.3118. We just need to figure out what August 5th is. August is what, 08? 0518. So now if you go into your calculator, second date, you only have to change your date 1. So 08.0518. Enter. Just double check that date 2 is still December 31st. It is. Days between dates, compute 148 days. Okay. So now I can fill that in. So 148 out of 365. Find T3. We've got date 1, date 2 is getting tedious now. That's good though. Date 2 is still 12.3118. And we've got June 23rd, 06.2318. So I'm going to just stay in the date function. Date 1 now is 06.2318. Enter. Compute the days between dates. I get 191 days. So I'm going to fill that in here. T3, I have 191 out of 365. So now we're going to solve for future value 1. Find future value 1. Future value 1 is P times 1 plus R times T, technically times T1, but it doesn't matter. Even if you just had future value here, that's fine. Right. I'm going to keep the subscript on there just to keep them straight. But P for future value 1 is that $1,300. $1,300 times 1 plus the rate is always going to be 0.0725. 0.0725. But the dates or the time is going to change, right? So this one I think was 61 days. Yeah. So 61 out of 365. So starting with 61 out of 365 times 0.0725 plus 1. I'll just stop and show my work. 1,300 times 1.012116438 times 1,300. $1,315.75. Okay. So on your own, just go through and find future value 2 and future value 3, and then we'll wrap it up next day. How about that? Some practice. / end a little bit early. Yeah. Yes. So once you have your future value 1, 2, and 3, I get 5452.13. But we'll go through it together next day. Yeah. Okay. Great. See you guys on Thursday, I guess. Not until the beginning of November. I think November 6th for you guys.
And that is